Hi, 6th grade. This video belongs with lesson 10.6, solve problems involving area of a circle. Here we have the formula. A equals pi r squared. A represents area, r represents radius, just like in lesson 10.5. But unlike lesson 10.5, notice there's not two different ways we can write the formula. In lesson 10.5, we could find circumference whether we had the radius or the diameter. In this lesson, for area, you have to have the radius. Okay. Also keep in mind order of operations. So if we think of GMA, or grouping symbols, exponents, multiplication, division, addition, subtraction. When we use our order of operations, exponents come first, so we would square the radius, then we'd multiply that value by pi. Also, like in lesson 10.5, there's three ways you can write your answers, as you see here. It might ask you to write your answer in terms of pi, or it might tell you to use 3.14, and then I've told you that you can use the pi button instead, since that's what you're going to have to use in future years. So taking a look at example 1, this is starting off very basic. We are looking at the area formula, and we want to find the area of a circle with a radius of 8 inches. We simply replace r with 8. 8 squared is 64. 8 times 8 is 64, and then we multiply that by pi. Okay, so if they want us to leave the answer in terms of pi, we just write it as 64 pi inches squared. Area is a square unit, so don't forget your inches squared. And the reason why we want to put the 64 in front of the pi rather than having it behind is just, it's the same reason why you have a coefficient. You would say 3x, not x3. So pi, that symbol, works the same way as a variable. If you want to use the pi button, you would have to round at the end, keep 2 decimal places just like we did in lesson 10.5. You're going to continue to keep 2 decimal places or the hundredths place for the rest of this school year. So you would end up with about 201.06 inches squared. Or if you use the 3.14, so if you round before you find your final answer, you're going to be even more off. Okay, but it's acceptable for pre-algebra to use 3.14, and you would get 200.96 inches squared. Remember, this symbol here you do not have to use, but we're going to be doing a lot of rounding in this chapter, so that's why I include it. It's habit, it's a math thing. You do not have to use it. It just means that we rounded. Okay, example 2 is going to be very similar, but in this problem, the circle they give you the diameter, not the radius. And as we said above, in the formula, you have to have radius. Well, luckily for us, we're pretty good at dividing values by 2. So if the diameter is 36, our radius is going to be half that, or divide by 2. Our radius would be 18. Now we just plug in. Pi times radius squared would be 18 squared, which is 324. 324 times pi. And again, I went ahead and wrote the answers in 3 different ways, just like you saw in example 1 and in lesson 10.5. If it doesn't specify, you can leave your answer in any of the 3 ways. Don't forget to square your label since area is squared. For example 3, we're going to switch it up a little bit. This one's going to be a little more complex. We're actually going to work backwards. In this problem, we're asked to find the radius that has an area of 28.26. So we are given A, we don't know what R is. Okay, and it wants us to use 3.14, which is nice in this problem because then we get a nice value in these later steps here. So if I use my formula, I replace A with 28.26. I'm going to go ahead and replace pi with 3.14. R squared, so I need to get R by itself. So I'm going to divide by 3.14. 28.26 divided by 3.14 is 9. And now we have a topic, or an equation here from topic 2, where we have a squared number. Well, so we're trying to find what number times itself gives you 9. Well, technically that could be positive 3 or negative 3, because 3 times 3 is 9, and negative 3 times negative 3 is 9. But we're looking for a measure, so the negative answer doesn't make sense. So I included the plus or minus here in my step of work because I like to stay in good habits, and I know that's what I learned in topic 2. But since this is measure and you're only focusing on positives anyways, you can just go straight to, well, 3 squared is 9, so your radius has to be 3 feet. And with this is not going to be a squared unit. They gave us area, which was the squared unit. We're trying to find one dimension of the area, so that's why it's just feet. Okay, so that's probably the trickiest these get, just because we haven't done square roots in a while. Remember, square roots are the inverse operations of squaring, so that's why if something is being squared, you can take the square root. If you want to go back to topic 2 and review, feel free to go to Pearson or your notebook, but that's all that we're going to be using from topic 2 in this chapter. All right, moving on, the next type of example that we have is incorporating circumference with area. So in example 4, what is the area of a circle with a circumference of 25.12 meters? And again, we're going to use 3.14, and that's going to just make it so that our values are a lot nicer. Excuse me. Well, if our ultimate goal is to find area, we need to know radius. So we're going to use circumference and work backwards to find radius. So this was one of the problems we did in 10.5. I'm going to use c equals 2 pi r instead of c equals pi times diameter, because my goal is to find the radius. So it'd be more work, technically, I guess, if I use the other formula, when if I use this one, it's going to get me straight to what r equals. So I'm going to replace c with 25.12. I'm going to replace pi with 3.14. Well, 2 times 3.14, clean that up, that's 6.28. To get r by itself, I'm going to divide 6.28 to the other side, and when I divide, I get 4. That means my radius is 4. And I don't have that extra step of taking the square root because I'm not using the area formula here, I'm using the circumference formula, so don't get those confused. Now that I know that the radius is 4, I'm going to plug that into my area formula, and I'm going to continue to use 3.14 since that's what it told me to do. So 4 squared is 16. 16 times 3.14 gives me 50.24 meters squared. So that one takes a couple steps, but it's using what we learned in the last lesson. And our last example, this one's going to look pretty complex, but it's actually not too bad. It just has a couple of extra steps. If we want to find the area of an entire figure, and that figure is made up of different shapes that we are familiar with, we want to split that figure up into multiple shapes. So here we have a rectangle and a circle. And all they're telling us down here is the base is 20 centimeters and the height of our rectangle is 26 centimeters. So let's split this up into what we know. We know the area of the entire figure is the area of the rectangle plus the area of half a circle. And it is always going to be safe to assume that these are half circles whenever you're dealing with figures like this. So if you have like one on each side, that would be 2 halves of a circle, which would add to be a full circle. So it is always okay to assume they're giving you half the circle. So area of a rectangle is length times width. So I'm only focusing on the rectangle itself, 20 times 26, which is 520 centimeters squared. For the half circle, I'm going to take the pi r squared and take half of it. Now here's where we have to do a little bit of interpreting. Well, if the base of the figure is 20, then that means this value here is also 20, and that's going to be the diameter of your circle. In order to use area, we need the radius. So we're going to take that diameter and we're going to divide it by 2. That means the radius of this circle will be 10. And we plug in. It told us to use 3.14. So half of the formula would be 3.14 times 10 squared. 10 squared is 100. Half of 3.14 times 100 would be 157 centimeters squared. So that allowed us to find the area of the rectangle and the area of the half circles separately. And to find the area of the entire figure, we need to add those values together. We are looking for area, so don't forget to label 677 centimeters squared. Okay, so the most complex as far as these problems, or I guess the most steps you might see, will be problems like example 5, where you're going to need to split up into multiple shapes. Split up into shapes that you know. It would not make sense to split this up in half height-wise, because then we'd end up having to split it up into 4 shapes. So split it up into areas you know, find them separately, and add them together. And that wraps up our video for lesson 10.6. So if you have any further questions as you're working through the problems and this isn't helping you, make sure you reach out and let me know.